In last video of standard deviation, we have discussed how to calculate standard value of the standard deviation in a case of discrete series. We have discussed both of the methods. One is direct method and second one is assuming method. In today's video, we will learn how to calculate standard deviation in a case of the discrete series from direct method as well as the assuming method. So already I have mentioned on the blackboard, we are having a case of discrete series problem is over there. The value of x is given 10, 12, 14, 16, 18, 20, 22 and 24. The frequency of the item is given 5, 8, 21, 24, 18, 15, 7, 2. The total of the frequency is 100. So the very first I am using direct method. For calculating standard deviation from the direct method, the very first we want the arithmetic mean. So the value of arithmetic mean x bar will be having sigma fx divided by sigma f. So for calculating f multiply x, the very first we want fx, okay. So we are calculating f multiply by x. The very first we have to calculate value of fx. So the very first value is 50. Then 12 multiplied by 8, that is 96. 50, then 96. Then 40 multiplied by 21, that is 294. 16 multiplied 24, that may be 384. 18 multiplied by 18, that is 324. 20 multiplied by 15, that is 300. 22 multiplied by 7, that is 154. And 24 multiplied by 2, that is 48. So the addition of this all items is 1650. So for getting arithmetic mean, this value is 1650 divided by 100, that is 16.5. So we have calculated the value of x bar, that is 16.5. Now the value of d, that is x minus x bar. What we are to do here? Deviation 10 minus 16.5. 10 minus 16.5, that is minus 6.5. 12 minus 16.5, that is minus 4.5. 14 minus 16.5, that is minus 2.5. 16 minus 16.5, that is minus 0.5. 18 minus 16.5, that is plus 1.5. 20 minus 16.5, that is 3.5. 22 minus 16.5, that is 5.5. 24 minus 16.5, that is 7.5. So this is the value of dx. We have calculated deviation from the real arithmetic mean. Now we require the square of d square x. We require this d square x, and f d square x also required by us. So the value of d square, 6.5 multiply 6.5, 42.25 multiply by 5, 211.25. 4.5 multiply by 4.5, 20.25 multiply by 8, that will be 162. What I am doing? Firstly, I am getting the square, and then 42.25 multiply by 5, that is 211.25. 2.5 multiply 2.5, that is 6.25. Multiply 6.25 to 21, sorry. 6.25 multiply by 21, that is 131.25. This is 0.5, so 0.25. 0.5 multiply 0.5, 0.25 multiply 24, that is 6. 1.5 multiply 1.5, 2.25. 2.25 multiply by 18, 40.0, 40.5. 3.5 multiply 3.5, 12.25. Multiply by 15, 183.75. 5.5 multiply by 5.5, 30.25. Multiply by 7, 211.75. 7.5 multiply by 7.5, 56.25. Multiply by 2, 112.5. So the very first what we have done 7 point. Okay. So addition is 1059. 1059.00. So the very first we have taken the deviation from the real arithmetic mean, getting this ds, dx, we will write here d and d square, f_d square. Okay. So the value of standard deviation, that is sigma f_d square divided by sigma f. So 1059 divided by 100. So the standard deviation is equal to 10.59. The value of standard deviation will be 10.59. So getting the square root of 10.59, 3.25. So the value of standard deviation is equal to 3.25. Coefficient of standard deviation, that is standard deviation divided by x bar, 3.25 divided by 16.5. 0.197. Coefficient of variation, CV, standard deviation multiplied by x bar 100, 3.25 multiply 16.5 multiply by 100, that is 19.7%. So if two series is given and if any, that is asking where the variation is high. So where this may be high, there will be more variation. So in this question, with the use of the direct method, we have calculate how to calculate standard deviation. Very easy to calculate the standard deviation. The very first we have calculated arithmetic mean, then take deviation taken from the real arithmetic mean. This is the value of deviation. We make the square of this deviation and then multiply by f and d square, f_d square. Multiply f multiply d square and getting the addition of this sigma f_d square, the value of this. Then using the formula, we calculated the value of the standard deviation. It's very easy to calculate with the direct method. The same question we can use here. We are having get the 16.5. So getting this deviation in percentage point. To avoid this, we can use the assume mean method also for calculating standard deviation. So we are another method we are using, that is called assume mean method. Same question we will do with this. So we doesn't require all these items. The same question is lies and we are using assume mean method in this. Which method do you like, you can solve with this, no problem at all. In examinations you are free to use any for assume mean method. In assume mean method, we may assume any one of the item as a arithmetic mean. Suppose in this we are using 16 as a arithmetic mean, so A is equal to 16. So the dx is equal to x minus A. So we assume our arithmetic mean is 16 suppose. So then 10 minus 16. So dx is equal to minus 6. 12 minus 16, that is minus 4. 14 minus 16, that may be minus 2. 16 minus 16, that may be 0. 18 minus 16, that may be plus 2. 20 minus 16, that may be plus 4. 22 minus 16, that may be plus 6. 24 minus 16, that may be plus 8. So this is our dx. D square x, addition of dx 6, 4, 2, minus 12, okay, minus 12, remaining plus 8. Assume mean, for getting assume mean, okay. Now we require, this not required, we require d square x, okay, d square x, that is 36, 16, 4, 0, 4, 16, 36, 8, 8 ja 64. We get the square of dx, 6 multiply 6, that is 36, 4 multiply 4, that is square of 2 is 4, square of 2 is 4, square of 4 is 16, square of 6 is 36, square of 8 is this. Now we require f dx and require f d square x. F dx 5 multiply 36. For getting, this not required. It will create confusion, so I am removing this. Okay. So the value of dx is available. 5 multiplies minus 6, that is minus 30. 8 multiply minus 32. 21 multiply minus 2, minus 42. 22 multiply 0. 18 multiply 2, 36. 15 multiply 4, 60. 7 6 ja 42 or 8 2 ja 16. So this is our value. 30 minus 32 is also minus, 42 is also minus. 36 plus value, 60 plus value, 42 plus value, 16 plus value. So remaining this sigma f dx is equal to 50. Now we require multiplication of f guna d square, that is 36 multiply by 5, that is 180. 36 multiply 5, 16 multiply by 8, that is 128. 4 multiply 21, that is 84. 0 multiply 24 is 0. 4 multiply 18, 72. 60 multiply 15, 900. No, wrong. 16 multiply 15, 240. 36 multiply 7, 252. 64 multiply 2, 128. So the addition of this is 1084. Addition of this is 1084. Okay. Now x bar, assume mean plus sigma f dx upon sigma f. The formula for the assume mean method from arithmetic mean, that is assume mean plus sigma f dx upon divided by sigma f. So here our assume mean is 16 plus 50 divided by 100, that is 16 plus 0.5, that is 16.5. So arithmetic mean already 16.5. In direct method also we get the arithmetic mean is 16.5. For calculating standard deviation, the formula will be used sigma f d square x upon sigma f minus sigma f dx upon sigma f raised to power 2. Okay. So here 1084 divided by 100 minus 50 divided by 100 raised to power 2. So that is 10.84 minus 0.5 raised to power 2, that is 10.84 minus 0.25. $10.59 under root of 10.59, that is 3.25. Already we have discussed in direct method also we have discussed the standard deviation value is 3.25. So value of standard deviation, that is 3.25. Coefficient of standard deviation divided by x bar, 3.25 divided by 16.5. $0.197. Coefficient of variation CV, standard deviation divided by x bar multiplied by 100, 3.25 16.5 multiplied by 100, that is 19.7%. So for calculating the coefficient of variation also you can calculate. So in this video we have discussed how to calculate standard deviation in a case of discrete series is over there. We have used both of the formula. One is direct method and second one is shortcut method, or we can say assume in method. Which of the method you may be like, you can use this. You do not want to learn both of the method, if the calculator is allowed, no problem at all, because in examination never they ask calculate the standard deviation with the assume in method or direct method. Sometimes a very rare case they may ask, but we have discussed both of the method. Whether you like direct method, you can solve with the direct method. Whether you like the assume in method is better, you can use this. I think this video will be beneficially for learn you how to calculate standard deviation in a case of the discrete series. Thank you.